Hello, everybody. And it is Sunday, March 28th, and welcome to Elementary Astronomy Online. We're about to head into Module 11. But before that, I want to tell you, before I forget, that the Perseverance rover that's on Mars will be flying its helicopter, not this coming week, but they've said no sooner than April 8th. And so that's when the little helicopter Ingenuity will be flying over the Martian surface on a test flight. So I'll let you know more about that next week when I make a video for next week and know a little bit more, but right now it won't be any earlier, they say, than April 8th. But what's ahead this week? Well, we're going into Module 11, and that is a module that describes the lives of the stars, how stars are born, how they live their lives, and how they die. It's the story of stellar evolution. Now, when we talk about evolution of animals, we might mean how a horse developed over millions of years from some ancestral animal that didn't look very much like a horse. But over millions of years, mutations happened, natural selection operated, and that sort of pseudo horse eventually evolved in today's modern horses. Now that's the biological meaning of the word evolution, but in astronomy, when we talk about stellar evolution, we mean the changes that occur in a single star during its lifetime. So it's like the story of you or me as we age. And stars go through huge changes. And that story starts out in a cloud of gas and dust. And if you take a look over my shoulder here, you can see those clouds of gas and dust just up there, just spread around. They're all over space, these dark lanes of gas and dust that are hiding the stars behind them. And if you stop to think about our bodies as we age, you know, when we were born, we were just a small child. And today, here we are. Where did all this stuff that's in our bodies come from? You know, well, because we didn't, all those atoms had to come from somewhere. When we were just a little baby, you could hold in your hand. Where were those atoms that right now make up our bodies? And the answer is they came from the food that we ate and the air that we breathe. And where did that food come from? Where did the air come from? Well, I mean, the food came from the ground and, you know, got absorbed into the corn we eat, or animals ate grass, and that is the eat we eat if you're not vegan. And those atoms added to our body's mass. And so did the air we breathe. We breathe in a combination of oxygen and nitrogen mostly, some oxygen, some carbon dioxide. And those atoms too are incorporated into our body. So where did those atoms that are in the land and in the air come from? And the answer is they started out in those dark clouds of gas and dust that you see over my shoulder there. Those clouds gravitationally collapsed to form stars and planetary systems. Those stars aged. You'll find out that those stars grew large. Our sun is going to grow into a giant star. Other stars, more massive, will become even larger than our sun will become. And then the most massive of those stars exploded. And the explosion of those stars expelled all the atoms, all of the heavy atoms that were manufactured in the centers of those stars by nuclear reactions. All those atoms were scattered into space. And they collected into clouds of gas and dust that you see behind me. And those collapsed to form new stars, and so on and so on. And so quite literally, the story of our body You know, each of our bodies is the story of the life history of stars. So if you ask, for example, if you look at your hand, you know, where did the bones in my hand come from? Where did the calcium in my skeleton come from? Those calcium atoms were formed, were manufactured inside stars, and about half of the calcium atoms were spread out into space by exploding massive stars, and about half of them were spread into space by less massive stars like our sun that will eventually puff off their outer layers and then perhaps will themselves explode if they're in a binary star system. So all of the atoms in your skeleton were manufactured by stars. Some of the heavier elements, if you have gold or silver, copper, or even heavier atoms, some of those atoms were manufactured by the collisions of very heavy stars called neutron stars. And you'll learn about neutron stars too. Neutron stars and black holes are formed by the death of the most massive stars. Or when our sun finally expires, it will form a small, dense ball that's called a white dwarf. And you'll learn about a white dwarf star. So it's a fantastic story that you're going to be learning. Where did all of the atoms that form everything you see around you, the wood in your table, the plastic that's in your drink bottle, your water bottle, where did all these atoms come from? And they're manufactured by stars in one way or another. So that's what you're going to be learning about. It's a fascinating story. It's one of the great stories of astronomy, and that's what Module 11 is all about. Now, let me just take you to the night sky. So I want to share the screen and take you to the night sky. Here we go. This is what the night sky is going to look like tomorrow night, Monday, around 9 in the evening. And as I said last week, the constellations are slowly shifting to the west as Earth orbits the sun. And so we have to look over to the west to see familiar sights, like here's Orion up here. And here's Sirius, the brightest appearing star. But what is amazing is that right now you can see all of the stages of the sun's evolution right in this portion of the sky. For instance, let me show you this. I'm going to take a look at this region of the sky that's right below the 3 stars that form Orion's belt. So I'm going to drag that to the center of the screen, and I'm going to zoom in on to the Orion Nebula. And right there is the Orion Nebula. If you have a pair of binoculars, you can look at this region of the sky and see the Orion Nebula. It will appear faint. You need a pretty good telescope to get a view that looks like this, but you can see the glow of the Orion Nebula with binoculars if you want to take a look tonight. And this is a region of the sky that you can see there's a cloud of gas and dust surrounding it. And here's a big hole in the nebula. So you're looking inside and you're looking at new stars that are now forming and new solar systems that are now forming. So the Orion Nebula is a big stellar nursery. And our sun was formed in a stellar nursery very much like that, perhaps about 5 billion years ago or so. So I'm going to zoom out from that. Go back to a natural view of about 60 degrees. Here we are looking southwest. And of course, from that cloud of gas and dust that collapsed to form our sun was formed. And you can certainly see our sun during the day. Don't look directly at the sun, of course, but you can see it during the day. But as our sun ages, it's going to become a red giant star, very much like Betelgeuse is. Betelgeuse happens to be larger. It's more massive than our sun. It's going to be larger than our sun, but still our sun is going to become a red giant star. So the Orion Nebula is the past of our sun. Betelgeuse is like the future of our sun. And then finally, our sun is going to puff off its outer layers to expose a bare core that's made of carbon and oxygen, and that's a white dwarf star. And if we look over here at the star Sirius, the brightest appearing star in the sky, Sirius is really a binary star. Now, the main star Sirius is just a very bright normal star, but the binary star is a white dwarf. It's the first white dwarf discovered. You need a very powerful telescope to see it, but it's right there. It orbits the star Sirius. And so there's every stage of our sun's evolution, from Orion Nebula to our present sun, to a red giant, to a white dwarf. So I do hope you enjoy learning about this story, and let me know if you have any questions. As always, you can email me. I'll be happy to set up a Zoom. I love hearing about this, and be sure and watch the videos because there's some great videos about this topic. So have a great week. Again, contact me if there's anything that I can help you with, and I'll look forward to seeing you next week right here. So until then, have a great week, and I'll see you next time. Bye-bye.